This video is for Module 2, Part 8, and includes a discussion of margin of error and confidence intervals. Okay, let's go ahead and get started. So recall, a statistical hypothesis test is a process to determine whether or not data from a study supports the research question posed. This process requires one to specify the value of the parameter to be tested. In contrast, a confidence interval does not require pre-specification of a parameter. The purpose of a confidence interval is to provide a likely range of values for a parameter. Like a hypothesis test, a confidence interval does require obtaining a reference distribution so that we can gain an understanding of likely versus unlikely values. Okay, so let us consider the following illustrations, which will demonstrate the difference in the construction of a reference distribution for a hypothesis test versus one for the calculation of a margin of error. The reference distribution for a hypothesis test requires the specification of a parameter value. So here I've specified that to just be pi equal 25%. Suppose the outcome from a study is 12. So again, the purpose of a hypothesis test is to determine whether or not 12 is an outlier against this reference distribution. We use a p-value to measure the amount of, or the degree to which that study outcome is an outlier. Now, what we're going to do when we construct a confidence interval or a margin of error is move that reference distribution or slide that reference distribution up underneath our study outcome. Now, the reason we do that is because we do not pre-specify a value for a parameter. So we're going to put 12, which is the study outcome, we're going to have that be the most likely outcome in our reference distribution. Let's talk a little bit about the margin of error now. The margin of error is the acceptable amount of inherent variation in a reference distribution. The acceptable amount is simply the amount that will capture the likely values from this distribution. So if we use the 5% outlier rule, the likely values are the middle 95% from this distribution. So what we're going to do is truncate or ignore the lower 2.5% of this reference distribution. We're going to truncate or ignore the upper 2.5% of the distribution, and what is going to be left is that middle 95%. In this particular illustration here, it looks like after truncating the distribution, it's at about 9 and 15. So again, the study outcome was 12 here. My reference distribution after truncating is going to be 9 up to 15. We call that range of values from 9 up to 15, or that range that captures the middle 95%. We call that the 95% confidence interval. Now, the margin of error is just that distance that I need to go from my study outcome up to that right edge of the distribution. So if I'm going up, I'm going to be using the positive margin of error. If I'm going down, I'm going to be using the negative margin of error. Now, almost always when we're talking about margin of error, we'll talk about the plus and minus margin of error. And what that just simply means is that from my study outcome, I'm going to go up and down a certain distance, and that distance is called the margin of error. And what that allows us to do is understand what values are likely to occur over repeated sampling from my population. So in this schematic right here, the outcome from the study was 12, the lower edge was 9, and the upper edge was 15. Now when we express the margin of error, it's almost always expressed as a percentage and not as a count. So this scale right here is the count axis. Now to convert that to percentages, all I need to do is just take each of those corresponding values and divide by the total number of trials, which in this illustration is 28. So if I do that, the outcome from the study is going to be 12 divided by 28. That's going to be 43%. The lower edge is going to be simply 9 divided by 28. The upper edge will be 15 divided by 28. So my confidence interval is going to go from 32% up to 54%. That would be a 95% confidence interval for this illustration. And what the margin of error is, again, is just the distance from the edge of the distribution back to the middle. So if the upper edge of the distribution is at 54% and the middle is at 43%, then the positive margin of error is just going to be 54% minus that 43%, which is going to be positive 11%. And then the lower end is simply going to be the lower endpoint expressed as a percent. So that lower edge expressed as a percent is 32%. And the outcome from the study, again, is at 43. So I just take 32 minus that 43, and I would get negative 11%. So again, these almost always go together, or we would express that as a plus or minus 11% for this illustration that I have. Okay, so let's go ahead and calculate a confidence interval for an example, and not just for an illustration. Consider the following poll done by the Star Tribune, which is a newspaper from the Twin Cities. What they did is they obtained a sample of 625 registered voters. So the survey under consideration here is related to the opinions regarding stricter gun laws in the United States. So here's some of the information that they provided on the poll. They tell us right here a little bit about what the scope of inference is going to be in the study participants. So it says the Star Tribune poll interviewed 625 Minnesota registered voters between certain dates about gun ownership. The question that they asked, among other questions, was, do you support or oppose stricter gun laws in the United States? 56% supported that, 31% opposed that. These percentages don't add up to 100%, so there must have been a box for undecided, or they didn't present the outcomes for undecided. Okay, the most common way that we would graphically present information like this would be just with a side-by-side bar chart. So something real simple like this, where I have the support that goes 56% and oppose is 31%. The scale here is just the percentages. Now, suppose the Star Tribune took another poll of 625 registered voters. The proportion of study participants who respond with support will be different. Okay, so it should be close to that 56%, but we certainly are going to have variation from sample to sample in this percentage. And again, that's the goal of the margin of error, is try to understand what that percentage or that inherent variation is. So here's a couple of graphics here. So let us consider graphic A first. Graphic A has a lot of sample-to-sample variation. So what we mean by that is that over the repeated sampling from the population, this bar is going to vary quite a bit. And what I have drawn here, it looks like it's going to vary from 46% up to about 66%. So that would be my confidence interval, is just the degree to which that bar varies over the repeated sampling. Now the margin of error again is just going to be the distance from the upper edge to the middle. So the middle of this range is going to be 56%. So 66 minus 56 is just 10%. So my margin of error is going to be plus or minus 10% here in what we have on the screen. Now graphic B is something very similar, except it has a lot less sample-to-sample variation in it. So here you can see that over the repeated samples, the amount that that bar is going to change is substantially less in the graphic B than compared to graphic A. Again, where that bar kind of on the lower end would be 52%. So in other words, I wouldn't expect that bar to go below 52%, nor would I expect this bar to go above 60%. So that's the confidence interval here, is just that 52 to 60%. The middle again is at 56%, so the margin of error here is plus or minus 4%. So what we need to do with our reference distribution is, again, gain an understanding of how much sample-to-sample variation I'm going to have over the repeated sampling. Is it going to be in a situation like graphic A, or am I going to be in a situation like graphic B, where I have a much smaller amount of sample-to-sample variation and hence a much smaller margin of error quantity? Okay, so how do I get the margin of error via simulation? I'm just going to use the reference distribution app. Again, I'm going to specify the number of trials to be 625. The proportion that supported stricter gun laws, that's going to be 56%. Okay, so again, when I'm building the reference distribution for a confidence interval or a margin of error, I'm just going to use the outcome from the study. Now we call this quantity here a point estimate. Okay, that's just my best guess for what the parameter would be. So your best guess is just going to be the outcome from, or the data that you got from your study. Okay, so let's just take a minute and get the terms, or identify the following quantities here for this example. So my scope of inference is going to be Minnesota registered voters. Okay, so again, they told me that in a description of the poll that they took. So they interviewed 625 Minnesota registered voters. So my scope of inference here is Minnesota registered voters. The parameter is just the proportion of Minnesota registered voters who support stricter gun laws. Now my study participants, which is different than my scope of inference, my study participants is just the 625 Minnesota registered voters who participated in this study. So we're going to use these 625 people that participated in this study to try to make a decision about, we're going to use these people here to try to make a decision about the Minnesota registered voters, all Minnesota registered voters. My statistic, or my point estimate, is just that 56%. What I'm really interested in is not just the 56%, but what would the proportion be for all Minnesota voters? So again, my parameter here is the proportion of Minnesota registered voters who support. I don't know that quantity. I know what that quantity is for the people that took the survey. It's 56%. But I don't know that quantity for all Minnesota registered voters. So we're going to use the information from my sample to try to infer about what that parameter value is, or at least provide a likely range of values for that parameter. Okay, so how do we obtain the reference distribution? Again, we're just going to use the reference distribution app, as I said. We're going to specify the probability of success to be the 56% here. N is going to be the 625, and I'm going to use 10,000 repeated simulations. Again, the higher the number for the repeated outcomes, the better. So let's go about, how do we go about finding the lower and upper endpoints? So a couple of additional comments before I use the reference distribution app is only two-sided confidence intervals are going to be considered here. So we're going to want to select, sorry about that, we're going to want to select two-sided on my reference distribution app. We also are going to select the proportion of successes, as the confidence interval is done on the proportion scale instead of the count scale. So here on the app, you're going to want to select proportion of successes here. And then we just provide kind of an educated guess of where I anticipate that lower edge to be. We're going to have to refine this value, but initially I just provide a guess and then refine that or change that in order to get the desired level of 5%. Okay, so let's try guess number 1 here. What I'm going to do is put in my 56% here, 625 in my sample size. My number of samples is 10,000. I'm going to change the proportion of successes, and then I'm just going to try an initial value of 51, so 0.51 here. So I'm just looking at this distribution, and trying to kind of guess where the lower 2.5% is at. So again, I'm going to truncate off this red area here in that distribution. It looks like 51, a lower value of 51, is a little bit too conservative. The proportion of dots that are as extreme or more extreme than 0.51 is 0.011 here. Again, we're trying to make that value close to 0.05. What I need to do is move that 0.51 up in my distribution a little bit. It's too extreme right now. So let's try 0.52. So the only thing I've changed here is the as extreme as value down here to 0.52. And you can see when I get 0.52 here, I'm getting pretty close to the 5% level. So what values are as extreme or more extreme than 0.52 in this distribution? You can see that it's 0.0473. So that looks pretty darn close for a lower and upper endpoint. And what this is going to leave in the middle is that middle 95%, or the likely values. So here I'm actually going after the middle part of the distribution. The confidence interval is the middle part of that distribution. If I move this up to 0.53, you can see here that that's going to be too much. Now I'm too far into that distribution. So here I'm lopping off about 6% on each side, which is too much. I want to truncate or ignore about 2.5% on each side, and that's what I have about here, using a value of 0.52. Now I did provide a fourth guess where I'm just refining this even more. So here I'm using 0.521. Okay, so I'm just refining that more and more and more. And when I do that, I get a value very, very close to 0.05. So the lower endpoint, a reasonable lower endpoint, looks like it's about 0.521. If you use 0.52, that's certainly going to be close enough for me. So the confidence interval here is going to be from 0.521 up to 0.5999 here. So let's go ahead and interpret the confidence interval and the margin of error as well. So the 95% confidence interval for the proportion of Minnesota voters who would support stricter gun laws is 52.1% up to 59.9%. We usually express that here, as I have on the screen. The interpretation here is that we are 95% certain that the proportion of Minnesota registered voters who support stricter gun laws in the United States is between 52.1% and 59.9%. And this statement, again, is for all Minnesota registered voters, not just the 625 that were collected in our survey. If I wanted to know the proportion of Minnesota registered voters in our survey who supported stricter gun laws, I already have that answer. That's the 56% value. Now we can use this confidence interval to compute the margin of error. Again, I just go from each edge. So here I'm going from the upper edge, 59.9 minus the 56, and I get positive 3.9%. So that's going to be the positive margin of error, and then I would also have the negative margin of error. Now the the interpretation for margin of error is just the proportion of study participants who support stricter gun laws in the United States. That value is 56%. This value is expected to vary by 3.9% over repeated sampling. In practice, that's often written as it is here on the screen, just 56% plus or minus 3.9%. That's probably the most common way that you'll see this expressed in literature. We can also express that graphically. So sometimes they'll put these little indicators on top of the bars here, and that's just trying to express how high I can expect that bar to go. So here I can expect that bar to reach up to 59.9%, or I can expect that bar to go down as far as 52.1%. So again, I would not expect the proportion of Minnesota registered voters who support stricter gun laws to go below 52.1%. So a statement, if somebody made a statement that a majority of Minnesota registered voters support stricter gun laws, that statement would be true, because I wouldn't anticipate that value to go below 52.1%. So it's going to stay above 50%. Okay, so a majority would simply be over 50%, and I'm 95% certain that this bar is going to stay above 50%. In fact, I'm 95% certain that it's going to stay above 52.1%. And it's not going to go any higher than 59.9%. Now we could compute the margin of error for oppose as well. I'm actually going to have you do that down below. I'll say, okay, some comments then. In practice, the margin of error captures that middle 95% of the reference distribution. Okay, so when I'm doing these calculations up here, we almost always go after the middle 95%. We're going to lop off 2.5% on each side. That's so common that we don't usually communicate that we're using the 95%. So that 5% outlier rule is so common and so prevalent in practice that most of the time they don't tell you that they're going after the middle 95%. Also, a smaller margin of error is desired, as this implies that the statistic will not vary as much from sample to sample. So how can I make my margin of error smaller? Well, the best way, or the most efficient way to make the margin of error smaller, is to simply obtain lots and lots and lots more people. If I obtain a lot more people into my study or into my survey, then I'm going to be more sure about that proportion, that support for stricter gun laws. So if I have more people in my study, I'm going to be more sure about this 56% value. So therefore, the margin of error from a study that has lots and lots and lots of people is going to be less. So here I went ahead and just showed you what the distribution would look like if I added a couple thousand extra people into my survey or into my study. So here I have 2,625 people, and you can see that my margin of error is greatly reduced now. So up above, this distribution went from 56% down to about 52% and up pretty close to 60%. So my confidence interval here is pretty close to 52 to 60. But if I had 2,625 people, it looks like the confidence interval would certainly not go below 54% and would not likely go above about 58% here. So that confidence interval is much, much tighter when I have lots and lots and lots of people in my survey. And as a result, the margin of error is going to go down as well. Okay, so let us consider example 2.8.2. What we're going to do, or what I'd like you to do here, is just go ahead. We're going to look at the same poll, except I want you to talk about obtain a margin of error and a confidence interval for those that oppose stricter gun laws. So now you're going to be obtaining a margin of error and a confidence interval for this 31% instead of the 56%. So go ahead and use the reference distribution app here. You're going to be using 0.31 in here. You're going to be using 625 here. And go ahead and obtain lots and lots and lots of repeated outcomes here. Obtain the reference distribution. Make sure and change this to proportion of successes and two-sided. And then what you need to do is just start guessing values here. Okay, so you just try to make an initial guess here. So maybe I'll do that as an example, 0.26 maybe. So what proportion of the distribution is at or more extreme than 0.26? Okay, that's way too small. I need that to be close to 0.05 here. So you're just going to try to keep guessing or refine that value until you determine kind of what the lower edge of that distribution is and the upper edge of that distribution is, so that in the middle I got about 95%. Okay, so go ahead and play around with that app and try to figure out what the 95% confidence interval is. and then answer the questions down here below. So just what are your lower and upper limits? Provide an interpretation for me. Compute the margin of error for me here. And then just answer a couple true-false questions. Okay, that does it for Module 2, Part 8, our discussion of margin of error and confidence intervals. Thank you.